Hi everyone and welcome to another special video. My name is Emmanuel Olega and I'm a math teacher and also a software engineer. So today I'll be doing something special for you. Today I'll be going into mathematics paper 2, or what is actually called applied mathematics. Have you been having challenges with your math paper 2, the applied mathematics? I want you to know that now there is an answer for you. It's going to be made easy for you. I'll be teaching it in the most basic way that anyone can understand, with enough UNEB examples, with a clear demonstration of every single topic. All you need to do is just make sure you pay attention, get a notebook, copy, follow all the examples, and then if the exercises that I'll have at the end of each single section, just make sure that you're able to do them. So today I'll be introducing the topic of motion in a straight line. I'm going to be going to explain it to the core and to the basics. So today we're going to just introduce the topic. Alright, get a notebook, sit down, and let's learn something new. Alright, so now we're going to get to motion in a straight line, and that, as I've mentioned, is going to be our topic for today. So this is going to be one of the key vital topics in the kinematics part of applied mathematics, the mechanics section. Alright, so let's learn something new, and I believe it's going to be a smooth run for you. Alright, let's get started. So motion in a straight line. So linear motion deals with motion of bodies along a straight line. So what you do is just picture cars moving on a straight road, or probably anything that is possibly mobile, a bicycle, a motorcycle moving in a straight line, and that could include one motorcycle or more. So that's basically what we're dealing with here. So let's learn about the languages or some of the key terms that are used in motion in a straight line so that we have a better understanding. So one of the key terms is distance. So what does distance mean? So this is the length between two fixed points, and the units of distance are meters. So imagine the fixed points are two different towns, let's say New York and Washington DC. So length or distance is that length in between those two fixed points. But basically I think that makes sense. The units of distance are meters. And then we get distance from the calculation, or from the formula speed times time. So distance is the answer of distance is the product of speed and time. So that's how we calculate distance. Alright, let's look at another term. So this is a term that's almost similar to distance, but it's slightly different. So though in some cases the terms are interchanged, but we'll have a better understanding of this term displacement as we do different examples. So a displacement is the distance moved by the body in a specified direction, and the units of displacement are meters. So this is distance moved by body but in a specified direction, but we'll understand it better through examples. Alright, how about speed and velocity? So these are terms that are almost interchanged every time. So they basically have the same definition. So it's the rate of change of distance covered by the body. And then we know the units of speed are meters per second. So you can write that as m/s, or ms power -1. Now, speed is a scalar quantity and does not involve direction, whereas velocity is a vector related to speed. Its magnitude is the speed, but it also has a direction. When an object is moving in the negative direction, its velocity is negative. So basically I think you get the difference. So speed is a scalar quantity and velocity is a vector quantity, but they basically are usually interchanged in most of the questions, as we shall see. So how do we get speed? We've just seen from a formula that distance is speed times time. So that means if we make speed the subject, speed over velocity is equal to distance over time. Alright. Now acceleration is another term. So acceleration is the rate of change of velocity. The units of acceleration are meters per second, or m/s², or ms-2. So you can use it in any format. So you can use any of the two. They're all meters per second squared. Alright, and how do we get acceleration? Acceleration is equal to change in velocity over time. So just note that a body is said to be in acceleration when its velocity increases with time, and it is said to be decelerating when its velocity decreases with time. This is also known as retardation. So this is the term you just have to get familiar with. It means deceleration, or a body decreasing in acceleration over time. Alright, other important terms, one of those terms is uniform acceleration. So this is when the rate of change of velocity is constant. So if we display this in a displacement time graph, this is how the graph will look. So this is how we represent uniform acceleration. So I just basically want you to get an idea of how it can be displayed. So the graph will basically look like this once you calculate and get different values. So this graph is just for illustration, for you to get a picture of what it will look like. Yeah, just look at it and just understand it. All right, let's get to another one. Uniform velocity, this is the constant rate of change of displacement, and this is how we represent it. It's represented as a straight line with a constantly increasing value of gradient. The above diagrams are displacement time graphs. They can also be drawn as velocity time graphs, as they would look as below. Now you don't need to memorize these graphs. They're just meant to give you a picture and for you to just get a picture of what that graph would look like. How about uniform acceleration? Now this is more of a velocity time graph. So if we use the terms velocity against time, velocity on the y-axis and time on the x-axis, this is what the graph would look like. And then when it comes to uniform velocity again, now when you do it in a velocity time graph, this is how the graph will look. So uniform velocity simply means velocity is the same or it's constant throughout. That's why you see the velocity is 100 and it's constant even as time changes. Alright, so that's just to give you a picture. Alright, now next, as we get into this next session, these are also important values or formulas that you need to just remember. So remember, we've just said that speed is distance over time. How about average speed? Average speed is total distance over total time. And then also average velocity is different a little bit. So when it comes to average velocity, we deal with displacement. So average velocity is total displacement over total time. Alright, so let's look at a question. So this question will allow us to have a better understanding of whatever we've just discussed. So we gain a question. Question 1. A, B, and C are 3 points in that order on a straight line, with AB being equal to 5 kilometers and BC being equal to 4 kilometers. A man runs from A to B at 20 kilometers per hour and then walks from B to C at 8 kilometers per hour. Find total time taken to travel from A to C as part 1, and part 2, the average speed of the man for the journey from A to C. So it's something I want you to notice first. So you've seen that distance has been given in kilometers, and then the speed has been given in terms of kilometers per hour. So in this case, we're going to leave it that way. We're just going to make sure that our time is going to be in hours and the distance remains in kilometers. So when you're given time in hours already and distance in kilometers, you just use them that way, as we shall see. But if you're given the distance in terms of meters and time in terms of second, that is also okay. You can keep them that way, unless you have time in seconds when the distance is in kilometers. Then you may need to change something. But this will make sense as we do different examples. So let's see how this is done. So we're being asked to find the total time taken to travel from A to C. So here's the solution. We remember that time is equal to distance over speed. I think I mentioned that formula. So remember that from A to B, the distance is 5 kilometers. And then the speed from A to B is 20 kilometers per hour. So that means we have a 5 over 20 to find the time AB. So TAB means time AB. And what do we get? We get that as 0.25 hours. So the time is going to be in hours because the distance is in kilometers and the speed is in kilometers per hour. And that's the time taken to travel from A to B. But the question asks for time taken to travel from A to C. So that means we also have to find the distance from B to C. So to find the distance from B to C, the TBC is going to be equal to the distance from B to C, which is 4, and then the speed from B to C, which is 8 kilometers per hour. So when you divide those, you get 0.5 hours. So now that we know the distance, we know the time taken to move from A to B and then the time taken to move from B to C, definitely the time taken to travel from A to C is going to be equal to the total time AB and total time BC. So that's why you have 0.25 plus 0.5. Of course, the answer is going to be 0.75 hours, and hence we've solved the question. Alright, so question number 2 is asking us for the average speed of the man for the journey from A to C. We remember that the formula for average speed is total distance over total time. And then we remember that the total distance is going to be 5 plus 4 because we are dealing with now the total distance A to C. That's definitely 5 plus 4, and the total time is what we've just discovered in part 1. That's 0.75. So we end up having 9 divided by 0.75, which is equal to 12 kilometers per hour, and hence that is the answer. Alright, let's move to question number 2. So question number 2 says, a man walks 150 meters due north in a time of 70 seconds, and then 50 meters due south in a time of 30 seconds. Find the average speed as part 1, and part 2 find the average velocity. Alright, so let's solve this. Remember that average speed is equal to total distance over total time. So I want the average speed of the man. So let's find the total distance. So he moved 150 meters due north. So that means we have 150 meters as the first part, and then after that he moved 50 meters due south. So that means the total distance is the summation of the two, which is 150 plus 50. And then the total time, we know it took him 70 seconds to move north, and then it took him 30 seconds to move south. So the total time is 70 plus 30. So we end up having 200 over 100, which is equal to 2 meters per second. Now the reason we have the answer as 2 meters per second is definitely because our distance is in meters and our time is in seconds. Now, how about when dealing with average velocity? Remember that average velocity is equal to total displacement over total time. So now in most cases, total distance and total displacement are they're interchangeable, except in a few different cases. Now like this number, the value for total displacement is going to be different from the value of total distance, and here is why. We're saying the man walks 150 meters due north. So let's imagine the man started from this point, this dot that we have here, and he moved 150 meters due north. So that's 150 meters due north, and then we're saying, and after that he moved 150 meters due south. Now you know that south is in exactly the opposite direction to north, so that means he moved back by 50 meters. So that means at the end of the movement he ends up being somewhere around here. Now the difference with total distance and total displacement is in this case is when it comes to total displacement, we look at the length or the distance of the man from the original position where he had moved. So realize that even after he had moved and 150 meters due north and 50 meters south, we know that now the displacement is now basically the distance from the original position to where he stops. So that's why we only focus on this value or this distance right there. So that means our total displacement is now going to be equal to 150 minus 50, and that's how we get it. And then total time remains the same as 70 plus 30. So you have 100 over 100, and then therefore our average velocity is going to be equal to 1 meters per second. Alright, now this is just for you to note down and remember. So if a body or a particle is moving at a constant speed or constant velocity or uniform speed or uniform velocity, then the acceleration is 0. So when you have a question and there is such a thing as constant speed or constant velocity or uniform speed or uniform velocity, just remember that means that that body is not accelerating, and therefore acceleration is equal to 0. Now this is just something for you to note, and it's going to be important in some of the questions you're going to be covering. So just remember that, and we'll get to that as we do different numbers. Alright, let's look at another question. So this next question says A, B, and C are 3 points in that order on a straight line, with AB being equal to 60 meters and AC being equal to 80 meters. So a man walks from A to B at an average speed of 10 meters per second, and then walks from B to C in a time of 4 seconds, and then returns to B. The average speed of the whole journey is 5 meters per second. So we're being told the average speed of the whole journey is 5 meters per second. Then we are being told find 1, the average speed of the man in the second stage of the motion. And of course second stage is referring to the distance or the movement from B to C. And then part 2 is asking for the average speed of the man moving from A to C. And then the time taken for the third stage of the motion, that is from C to B. the average velocity or for the complete motion is part 4. That's what they want in part 4. So let's see how to solve this, but let's start with part 1, average speed of the man in the second stage of the motion. Alright, so in this case we have to first look at what has been given. So the distance AB is 60 meters, distance AC is 80 meters, speed AB is 10 meters per second, average speed for the whole journey has been given as 5 meters per second, and then the time BC is 4 seconds. Alright, so what to do is, it's going to be easier for us to work out such numbers by sketching something. So we've sketched a straight line, as you can see, and we've placed the different fixed points A, B, and C. And then we're going to label. So you can see that the distance from A to B is 60 meters, the distance from A to C is 80 meters. Now that we know what A to B is and what A to C is, it's definitely easy to find what B to C is. So B to C is definitely equal to 80 minus 60, which is going to be equal to 20. Now, the time, the speed he moved along AB is 10 meters per second, and that has been given. And then the average speed for the whole journey has been given as 5 meters per second. So now that we know this, we can now work out this number. Alright, so first things first, we know, because we're being told to find the average speed of the man in the second stage of the motion, that is from B to C. So let's work this out. So we're dealing with B to C. So we know that the time, total time to move from B to C is 4 seconds, and that has been given. And then the distance BC is known, and we know that is equal to 20 meters. So therefore it means average speed BC is 20 divided by 4, which is equal to 5 meters per second. And that is it for the first part. And then for part 2, we're being told to find the average speed of the man moving from A to C. So that means we need to know the total distance of A to C, which we already know as 80 meters, and we also need to know the total time taken to move from A to C. But there is a problem here, because we don't know the total time he took to move from A to B, so we need to find that somewhere. So we need to find the time from A to B. But we already know that the distance A to B is 60 meters, and then we also know the speed he moved along AB is 10. So using that formula, making time the subject, we can say time is equal to distance over speed. So therefore we can say the time he took to move from A to B is 6 seconds. Then the time to move from B to C is already known, and that is already 4 seconds. So that means the average speed of AC is definitely going to be equal to the total distance. So the total time, the total distance is 80, and then the total time AC is going to be 6 plus 4. So we have 80 over 10, and therefore we have that average speed being 8 meters per second. Then in part 3, we're being asked to find the time taken for the third stage of the motion, that is from C to B. That means in this question, the man actually returned, so there was actually a return journey. So after the man moved from B to C, after he moved from A to C the whole journey, we know that he came back and ended up at B. So at the end of the motion, he rested at B. So there was a return journey. So we need to know the time taken in that third stage of the motion. So how do we solve that? So first of all, we know that the distance CB is going to be equal to 20 meters. That is because BC is 20 meters also. And then the total distance of the whole journey we know is going to be equal to AC plus CB. So remember that he moved from A to C, which is the first outward journey, and then moving back from C to B. So that's the total distance of the whole journey, which is now going to be equal to 80 plus 20. And then we know the total distance of the whole journey is now 100 meters. And then to find the time from A to C, we know the time AC is equal to time AB plus time BC, and that is equal to 6 plus 4, which is equal to 10 seconds. So now the time from C to B is what we do not know, and that is what we actually want to find in this question. So that's the unknown value. But we also know the average speed for the whole journey was already given, and that was equal to 5 meters per second. So therefore, using the formula, average speed is equal to total distance over total time. So we're now going to be dealing with the whole distance. So we know the total distance is 100 meters as we've calculated, and then the total time for the whole journey is definitely supposed to be the times of AB, the times of BC, and the times of CB totaled together. But we already know the total time of AB and the total time of BC, and then we're only left with the total time of CB. B. So now making cross multiplying in this question, we end up having 50 plus 5 TCB, and then we know that 5 TCB is going to be equal to 100 minus 50, which is equal to 50. And then making TCB the subject, 50 divided by 5 is equal to 10 seconds. So therefore, the time taken to move from C to B is equal to 5 seconds. So that's, 10 seconds. That's the time for the third part of the journey, which is from C to B. Alright, so for part 4, we're being asked for the average velocity for the complete motion. So how do we find that? We know that average velocity is equal to total displacement over total time. Now remember that velocity is slightly different from distance. So now remember that we've just calculated our number, and you know that we have A, we have B, and we have C. So in our case, the man started from point A, he moved to C, and then he moved back and ended at B. So now what happens with displacement is we are looking at the distance from the original point where he started from. So he started from A and ended at B. So that means total displacement is this distance A, B. Alright, so that's how we're going to find total displacement. And of course, we know that the distance AB is equal to 60. And then the total time taken for the whole journey is equal to 20. That is because we've just found that TCB is equal to 10. And of course, 10 plus these other times is equal to 20. And that's what we have there. So therefore, average velocity is going to be equal to 3 meters per second. Alright, now next we're going to look at a question from UNEB. So this was a question from UNEB 2011, and this was question number 2. So the question was saying a car moves from Kampala to Jinja and then back. Its average speed on the return journey is 4 kilometers per hour, greater than that on the outward journey, and it takes 12 minutes less. So pay attention to those keywords. So given that Kampala and Jinja are 80 kilometers apart, find the average speed on the outward journey. So the outward journey basically means the journey from Kampala to Jinja, and then the journey back is going to be the other journey, that the second journey that actually happened. So there is him moving from Kampala to Jinja and then moving from Jinja back to Kampala. So that other journey coming back is what I would call an inward journey, or the journey back. Alright, so now in this case we can actually see that we've been given different parts, but now let's deal with different individual journeys. So now we're going to deal with one journey at a time. So now for the outward journey, we just know that when he was coming back from Jinja, we just know that on the return journey that the speed was 4 kilometers per hour, greater than that on the outward journey, and we're saying it takes 12 minutes less. So that means we're going to let a certain value represent the outward journey. So we're going to let the average speed of outward journey be x kilometers per hour. Then we're also going to let the time taken during the outward journey be equal to t hours. Now the reason we're going to deal with hours is because we can already see that our speed here is in terms of 4 kilometers per hour and our distance is in terms of kilometers. So we're going to convert everything to hours, and that will include these 12 minutes right there. So the time taken for the outward journey is basically going to be equal to t hours. Now we know that the average speed is equal to total distance over total time, and then we already know that now x is going to be equal to 80 over t for the outward journey. So x is that average speed, 80 is the distance from Kampala to Jinja for the outward journey, and then the total time taken is t, just as we've let it. So let's sketch something to just represent this. So now we have Kampala, Jinja, so there are two different fixed points. Now we know the distance in between those 2 points is equal to 80 kilometers per hour. And then we also know that we've actually let the speed from Kampala to Jinja be equal to x kilometers per hour, and the total time taken to move from Kampala to Jinja is as t hours. Now for the return journey, we've actually seen something unique being stated right there. We've been told that the average speed on the return journey is 4 kilometers per hour, greater than that on the outward journey. So that means we're going to add a 4 to the x. So we're going to have x plus 4 as the speed on the journey coming back from Jinja. And then we're being told that it also takes 12 minutes less. So that means from the time that it took to move from Kampala to Jinja, we're going to subtract off 12 minutes. And then when you convert minutes into hours, you can actually see that 12 minutes is equal to 0.2 hours. So that's why we have it as t minus 0.2 hours. Alright, so for the journey back, we can see that the average speed of the journey back is x plus 4 kilometers per hour. Then we've converted that from minutes to hours. Now 1 minute is equal to 1 over 60 hours. And then 12 minutes is definitely 12 over 60 hours, which is the same as 0.2 hours. Then time taken during the journey back is t minus 0.2 hours. So therefore the average speed, so we're going to derive a formula. So the average speed here is going to be equal to total distance over total time again. And then now we have x plus 4 being equal to 80 over t minus 0.2. Now, making x a subject, you can actually say that x is equal to 80 over t minus 0.2 minus 4. Now, we have something in this equation that is exactly similar to that we have in the very first equation. Now, we've actually made t minus 0.2 the LCM, and that's why we have a 0.8 at the numerator. And then when we solve that, we end up with 80.8 minus 40 over t minus 0.2. So now we have x in common between equation 1 and equation 2, and x value is the same. So now we're going to equate both of the equations. So we're going to equate equation 1 and equation 2. So we now have 80 over t being equal to 80.8 minus 40 over t minus 0.2. So when you cross multiply that, this is what we end up having. And then when we arrange these, we can arrange them to form a quadratic equation. Then using the quadratic formula, we can solve this. You can either use the quadratic formula or you can use your calculator. So you can see that t is going to be equal to 2.1 hours, or t shall either be negative 1.9 hours. But since time cannot be negative, we can actually say that t is going to be equal to 2.1 hours. So that's the part for that. So from equation 1, we can actually see that now we can actually clearly find some unknown. So now we can find out what that x value is, what the average speed on that outward journey is equal to, and that is what was being asked for in the question. So now we can find the value of x. So x shall be 80 over 2.1, of which x shall be equal to 38.1 kilometers per hour. And therefore the average speed of the outward journey is 38.1 kilometers per hour. Thank you so much for watching this video. I hope the video really helped you. If you did, feel free to tell me below in the comments. I'll make sure to get time to read through your comments and to reply to you. And also, if you're new to this channel, I encourage you to join the community by subscribing. And then make sure to hit the notification bell so that you get updated every single time I upload a new video. Again, my name is Emmanuel Olega. Thank you so much for watching. See you in my next video.